So now we're going to add a bit of turbulence to the plane's orientation and position. So what we're going to do is select our current target, the first target, the FW190A3, open the object graph, and what we're going to do is add another time cycle node. So add input MetaNode time cycle. And we're going to set the cycle time to 3. So over 3 seconds, we're going to have this amount of change. Actually, maybe 4.5, a little bit higher. The distance is going to be our position distance when used for position, or degree for orientation. We can really reduce the amount of nodes used by reusing the time cycle and just modifying the output of the distance. So 3 degrees might be alright for the orientation, but 3 meters for the distance, for the position, is going to be a bit too much. So let's go ahead and start with a lower value for the distance. I'm going to go ahead and set it to 0.5. And we're going to connect the Y of this composer to the cycle distance, and connect the Z to the same. So let's just go ahead and take a look for the position. And that might be a little too fast. So what we'll do is change our time cycle. Let's go ahead and bring it up to 6. And we'll go ahead and add a filter node opposite onto the Z link. And now if we go back into the graph, we're going to take a look at the orientation. And what we're going to do is take the value for the Z and link that somewhat to the Y orientation. And what we're going to do is add in a filter node, set it to multiply. Go ahead and multiply by 2 to begin with, maybe 3. And then connect that to our Y orientation. So now it's kind of bobbing up and down. If we take a look in the side view, the biggest problem is we're not really going through the full range. And I think maybe we should limit the amount of traveling on the Y. So we'll go in side to side. So we can select our connection to the Y and add a filter, setting it to divide by 2.5. And then I'm also going to modify that multiplier for the orientation. Let's bring that up a little higher. And we can take a look in the orientation and see how much change we're getting. And it doesn't look like a whole lot. Make sure we're taking a look at the local. And we might just need it to be a bit higher, unless we're just having sort of a conflict with the opposite, which is a possibility. So what we can do in that case is grab this opposite filter, selecting it, adding a new filter to create another opposite filter. And we're going to multiply the cycle distance first, and then do an opposite. And just try a higher value, 10. And that looks a little bit better. And from the front, it really wasn't that obvious, but now looking at it from the main camera, that could be a little too high. And a little bit of tweaking here and there. So let's go ahead and bring that down to 5 and take a look from the main camera. Always remembering that you do have different viewports. You're working in 3D, so it's important to kind of switch around and pay attention to everything, because what works in 2D doesn't necessarily work in 3D. So what I'm also going to do is set up Dynamics node delay for this Y rotation, and that will offset this just enough from the position. And we just need a little more rotation. This is a very linear turbulence. It's not really changing over time. We can make it change. But first, let's just add a little bit more to what would be the X. So what we're going to do is add in a combiner node, set it to add, and we're going to take as our initial value is going to be the multiply. So we're not going to do the inverse for the x-axis. And then we're going to add our previous time cycle that we're using to rotate the object and turn it once the other planes come by. But now we can have a little bit of turbulence as well, kind of bobbing back and forth. It looks a little better now. Adding just that little bit to the X rotation. And it looks a little more natural. The other value might be going up a little too high. So we'll create an alternate multiply, adding in another filter. Cycle distance, and let's go ahead and set this to 3.5. And this is going to be our modifier for the Y. Looks a lot better. So if we also want the camera to appear as if it's on another plane, following behind, we could also add a little bit of turbulence to the position of the plane. If you want, you can go into the setup we just created, and if you want to just copy and paste that over, it'll make it a little bit easier. And it'll certainly go a little bit quicker. So we'll just copy that, go to the main camera, paste it in, and we do want to modify the values so they're not completely the same. What we could do is just kind of offset it a little bit. So that way, if we were following within the same wind patterns, we could have a little bit of a delay before we reach that offset. So what I'm going to do is take the time cycle and use the time input, connect that to time, and then I'm going to add in a combiner, set it to subtract, time, add a constant, number, set it to 1. And that's going to have sort of a direct delay in the time, offsetting it by 1. Time cycle, if it's a negative delay, the offset might not be matching with the loop, so this way we can just offset it directly on the time, which makes that use time input very useful. So we have two values we want to modify. We're going to take the y and connect it to that division, and the z to the opposite. So now our camera has a nice bit of motion as well. And kind of bobbing up and down just behind the plane. And then if you want to change sort of that delay value, you can just change that subtraction number, make it 2, or you could reduce it if you don't want it to be quite as high. That looks like it should be good. We could also set up that turbulence on the other planes that are coming towards us if you wanted to have them be varied. But they're moving so quickly, I'm not sure it's completely necessary. One thing we could do is if we go into the node that has our constant, we could set up a time morph to change that value over time and kind of loop it. I'm going to go ahead and just set that up. That should be pretty simple. And that will affect both of them objects. So we'll go to the vector operations, or actually, we do need to go into combiner, MetaNode, time morph for auto additional. Go ahead and open that up and pull out our number, or auto number. And our start is going to be 10, and our end is going to be 8. We're going to set it for an endless loop. Make sure we connect that to time. And the amount of time spent moving between those values, we'll go ahead and set to 7, which should be enough. So just between, actually we'll go ahead and bump it up 11 to 8. Or maybe even 11 to 9. So 1 up and 1 down from the current value. And then we might want to set up maybe a slight delay on the Y position offset for the other object so that it's not completely identical. So dynamics, delay, let's say 0.3. So now we should see a nice change in the motion of the oncoming planes. And they'll just kind of zigzag or weave in and out based on the time morph. And it's very subtle because of the distance. And the transition time. So if needed, you could also change that to Let's do 4.8. And we'll see it a lot more frequently. Keeping in mind that it really doesn't start working until the initial transition takes place. So if needed, you could also set up another time morph for our other option here, the 7.5, the initial value. Because at first, with the other time morph set up for that separation, there's really no change until they start to change their orientation and spread apart. So if you wanted this other value to change, you could set up another time morpher, or you could kind of use the same values and just subtract the number to equal what it is that you want. That way we can avoid adding another morph and keep the function a little cleaner and less time needed for calculation. So we're going to add in combiner node, set it to subtract, add in a constant number, 2.5, and we're going to take the number output of the time morpher, subtract 2.5, and connect our previous value of 7.5 over. So now we should have change before the separation takes place, just a little bit of movement side to side. Might be able to see this better in the side view. Of course, remembering there is that little bit of a delay. And it looks like we've got a little bit of bouncing. So I might need to adjust the way that delay is set up. Go ahead and set it to 0.5. And if the delay is really an issue, we could always set up another time morpher. Or add in dynamics node and take care of the low pass to have a bit of a decay. And it doesn't look like that's going to work much for that. So in this case, we might just need to have them a little separate, and maybe we'll change the offset a little bit in one of them. We could also see if we can add in a delay for the vector and see if that helps. Because sometimes directly with the number it's not going to work, but on the vector it might autocorrect. And it does appear. Go ahead and change that just a little. And now it's got a nice offset. So on the vector, the delay works much better than just on the number. One last thing I want to show, and that has to do with once we return back to the starting tracked object, the FW190A3, it doesn't really transition very well. It doesn't kind of bounce back and forth. What we need is sort of a target that is going to be ahead of the plane and allow us to kind of bob back and forth. So what I'm going to do is go into our main camera, and within the graph, where we have our secondary transition going back to the original position, we're going to create a couple of different variations to ease it in a little bit better. So we're going to add, go ahead and copy, paste the time morpher, and we're going to connect this to the next part of the chain for the time. Pre-delay -1, we'll see how that's going to work. What we're going to transition is a bit to the distance in front of the object. So since we're moving 90 meters a second on the X, what we can do is just add using a combiner, set it to add. We're going to add in a constant vector. So constant node, constant vector. Actually, we'll go ahead and use a connectable constant vector in case we want to change this value or make it dynamic. And we're going to add to the X, we'll go ahead and add 45. So we're going to do half. So we'll take the external dependent, which is the position of the plane, connect it to that addition. So we're going to add 45 to that. So that's basically if we were a half second into the animation further, or a half second further. So the transition should go a little bit further than the plane. And then we also want to have a bounce sort of behind the plane. So we're going to modify the transition, which is going to be input 1 for this blender and the current morph. And then because we have a pre-delay set up, we're going to transition it to another object. Or another location, maybe not so far behind the object. So what we're going to do is we can copy and paste these values, and we're going to use -10. So just going behind the plane a little bit. And we're going to take these two and blend them. The combiner node, blender, clip our ratio, and we'll go ahead and turn on endless loop for now, and then we're going to have to ease it out with another delay afterwards. So maybe we're going back in the plane too far at the moment. So that -10, we'll go ahead and set to -2. And maybe -4. And then we'll add in one last transition, which is going to be one more blender going between 0 for that last connection we had. Actually, we can go ahead and bring it down, drop it one more level, and connect that to just the object position without any delay or offset. So now we could also set it up so that as this transition is going, that this one will go. The only problem is this one is set to an endless loop. So we might be able to judge the loop period, but we don't want this one looping. So we're going to go ahead and use input node, MetaNode, time cycle. And we're going to connect, we're going to say use time input, and we're going to connect to the time input, the time morpher. So that's going to offset everything except for when this morph starts. And while that is going, we're going to transition throughout our time, and the total time of this is 4 seconds. So what we can do is match a time cycle, make it 4. The distance per cycle we want to be 1. We're going to be using this to control a ratio rather than an actual distance. And we're going to turn on limit cycles to 1 and limit time. That way it'll cut off and end at 1 and turn off loop playback. Connect our ratio to the cycle distance and clip our ratio 0 to 1. And we'll go ahead and take a look at that. And it does look like it's jumping a bit. So in the time cycle, we're going to modify our spline. And it does look like we need to rearrange this just a tiny bit. There's one thing I did forget about. I'm going to disconnect the blender that we have on the bottom here. We just need to move that up because we actually need to be transitioning between the forward and backward x distance that we have and the fixed distance. So starting with 0, and we're going to connect to the main time morpher. And it does look like, because a time cycle is meant for really more repeating type functions, it is giving me little issues with just this portion of the setup. So I'm going to use the time morpher, which is probably going to work out a little bit better. What I'll do is just remove the time cycle, add in input node, MetaNode, time morpher. And I probably could get the cycle to work. But since we're working with so many morph chains, and time cycle really wasn't designed to be plugged into time morpher, so that's probably the issue that was showing up. Because of the way the time is output, it does go into negative numbers, and time cycle does clip those out. So that's probably the main difference. So if you're ever having trouble doing anything like that, switch over to time morpher. They both have their strong points, and of course their weak points as well, really depending on how you're using it. So what we're going to do is set up an identical morph to this other one, we're not going to have it on endless loop, and we're going to connect that ratio. And that should take care of that. And I did realize I did type in -4 instead of -1 for that new morph, so I'm just changing that. And because we have identical values, it doesn't quite end the way I'd like it to. So we have it going back, and it kind of bobs, but it doesn't quite reach where I want it to. So I am going to offset this value here. And what I'm going to do is take the transition and go ahead and make it 5. And we might need to just pull back that other number that we were working on earlier for the constant vector. Let's go ahead and try -6. And we'll want to loop this other one. Maybe get rid of the pre-delay, or add 1 to that delay. So that way we get to see a little bit more of the loop back and forth, and then start to transition into the fixed value. So that does work a little bit better. And just one last tweak to this. I'm going to make the pre-delay 0.5, transition 6, or we could even do a -0.5. Might work out a little bit better. And that does ease in a little nicer. So we have it coming back, going a little too far, and kind of working its way and leveling itself out. And if you want to add a little bit, a position change on the other axes, you could. So since we're coming around from this direction and kind of coming down, we could add a -z value for the upper. And maybe a slight positive. Or maybe a little bit negative. And we'll go ahead and do -1 on the y and set it to 0 for the z. So now we come back, go a little further, kind of go up and down a bit more. And that does transition much nicer. So adding just the other axis does make a big difference. Go ahead and scale the timeline, holding down Control and right-click. And that way we can scrub through the whole animation. So our plane flying through, and the other planes come, and they split apart, and turning. And we move back to the other plane. And then these planes will basically continue on forever. Because of the way time cycle is set up, they're adding that distance to the x, unless you were to limit the time. Taking a look at time cycle, limit time uses the same as the limit cycle amount for the limit. Limit cycles is more like limiting loops. Limit time will basically stop the time calculation altogether and cut it off at the end of the cycle. So that's the difference between those. Limit time is not part of the documentation because it is recently added. Same thing with the pre-delay, but that should be pretty familiar. That just offsets the start time of the time cycle. So that was added very recently. So it may not be in the documentation yet. So actually there's one more thing I want to show, and it has to do with the turbulence for the planes. This is a really cool thing you can do. If we open up our main target, the FW190A3, and we go to that top time cycle that's we're using to add our bit of turbulence, our distance per cycle is set to 0.5, and that is constant at the moment and being looped. If we want that to be more varied, what we can do is add in a noise node, and going to the preview options, we're going to change the object size of the preview to 100 meters, and that way we'll get a better idea of the range we're dealing with. I'm going to go ahead and set it over to a gradient, and we can bring it up to 40 for our scale. And this is going to give us an output. It looks like between about 0.6 and negative 0.6, around about there. So that's very similar to what we currently have for 0.5. So I'm going to extract the distance per cycle and connect it to that gradient noise node. So now the distance is going to be variable depending on the location of the noise. We can even offset the distance per cycle or the cycle time depending on this. So if we wanted to add, we'll go ahead and add a combiner node, extract our time cycle of 6, connect that, and then connect that to our gradient, and replace that connection. So now our cycle time is also modified depending on that noise. And if the values aren't quite high enough, you can add in a multiply node, or adding in a filter. I'll go ahead and set that to multiply. Multiply by 2. So now it's going to be variable depending on the noise. The noise can also be animated by turning on the animated function. So that's going to provide even more change. And you can see a lot more shakiness within the way the plane is moving. So if that's too much turbulence, what we need to do is reduce the connection to the time input. So to reduce the sensitivity overall of that time, we can use input node, MetaNode, time cycle, and turn off loop playback, limit our cycles to 0, reset the filter for the exit spline, and then our time cycle is basically the amount of time we want to stretch out. So let's go ahead and set our distance per cycle to 1, and our time cycle now is going to be how many seconds do we want to equal 1 second? So we could have it for every 10 seconds, return a value of 1. Let's use the time input. And then when we connect to our output, we have a couple of options. We could use the cycles passed. So for every 10 seconds, we're going to get what would be the equivalent of 1 second. So we're dividing it. So we could use the cycles passed in order to count those all up. But because the limit is set, we might want to connect that to time. So let's go ahead and take a look. And it's not nearly as bad because that animated motion can be a little quick. Let's go ahead and reconnect that to the cycle distance. And it looks like that's going to be a lot better because I believe the inside of the node, the time connection might not be modified entirely by the time cycle, just as a way to pass it through. So this will guarantee if we use the distance of 1, so for every 10 seconds we're going to get a value of 1 added. Also, if we go back into the node and connect that time to the cycles passed, making sure that limit cycles passed is turned off, it will count them if we turn on the correct values here. Turn off limit cycles, so this should allow a continuous amount to go on, and it's just kind of another way to break it down. One last note, you may have noticed that the secondary or the second object in the group for the two planes is no longer lined up with the other object in the other part of the group. That's because of the way the delay was set up. So there's just one quick change in order to correct that. Because I was talking about before connecting it to the vector, well, it does need to be connected to the vector, just not after the addition, because that is changing the current dependence. So what we're going to do is select this delay, click on the vector link here, and add in dynamic node, which will replace it, or add in identical delay, and then we can delete the other one. So now we're just delaying that y change, but through the vector instead of the numeric value. So it won't be jumpy anymore, or it still won't be jumpy, but the planes will match up to the original setup that we had. And if we were to go ahead and render this out, at the moment everything is dynamically linked. So even though we have animation when we scrub the timeline, we don't have the ability to play an animation or even access the render options. So we do need an object that is going to represent the amount of time we need in our animation. I typically just like to use a null object and add a position keyframe in order to make sure it's not interfering with any of the graph connections. So we'll go ahead and end this a little bit after that transition, and we'll go ahead and set it to 30. So we could also type in the value over here. At 30 we're going to select the ground and add in a position keyframe. So now we have an animation. So we'd be able to play it in the timeline. or render it out. To learn more about Time Morpher and Time Cycle, there are additional examples scenes included with the snowFlaKe content that's included with the product. So you can take a look at those scenes and learn how to do a few more things with it. It's a pretty versatile tool and very handy for animation.